Okay, in this video I'm going to do a couple of quick examples to show how to use that pH formula, and so we'll just work through them. Recall from the previous video that pH was equal to negative log of the concentration of the hydronium population. And if we want to use that formula the other way around, the concentration of hydronium is equal to 10 to the negative pH. So those were the two equations we had, and we didn't really use them, so there we go. A sample has a pH of 3.2. Determine the concentration of hydronium in the sample. What mass of sulfuric acid would be needed to be added to 500 milliliters of water to create this solution? So first of all, we are given the pH here, so we're going to use the secondary formula and recognize that the concentration of hydronium is equal to 10 to the negative 3.2. 10 to the negative 3.2. It happens to be 6.31 times 10 to the negative 4. So that's the concentration I want. Now I have sulfuric acid, so H2SO4, and it's going to react with water to produce SO4 2- and H3O+. We have a little bit of a trick here because this is a polyprotic acid. It has two hydrogens on the sulfate. That means that we need two waters for it to react with, and it's going to produce two hydronium ions. So here's my concentration of hydronium. I have a volume, 500 milliliters, so I can use C equals N over V here to get to an actual number of particles. 6.31 times 10 to the negative 4. N, and my volume is 0.5 liters. Remember, this equation requires liters. So the actual moles of hydronium that I want to get is 3.15 times 10 to the negative 4. This is in a 2-to-1 ratio with the actual sulfuric acid, so my moles of hydronium in comparison to my moles of sulfuric acid is in a 2-to-1 ratio. So if I have my 3.15 times 10 to the negative 4 moles of hydronium, then I can get my actual moles of sulfuric acid. Bring that up to the left-hand side and bring that down to the right, and I get, oops, not times, divided by 2. I get 1.58 times 10 to the negative 4 moles of sulfuric acid. And I actually was asked for the mass. So the last thing I'm going to do here is I'll use my moles to predict my mass by using my molar mass. Molar mass for sulfuric acid has 2 hydrogens plus a sulfur. Sulfur's 32, I think. Yeah, 32. And 4 oxygens at 16 each. .98 grams per mole. So 1.58 times 10 to the negative 4 moles of that. Mass on 98 grams per mole. And I get a mass of, that was supposed to be an M. Let's try that again. A mass of 0.0147 grams of sulfuric acid that would actually be required to make my 3.2 pH solution of 500 milliliters of sulfuric acid. So mostly this was a stoichiometry question, but at the beginning we saw how to use the pH formula. The concentration of hydronium is equal to 10 to the negative pH, so I just put the pH in as the exponent there. Using my calculator, came up with 6.31 times 10 to the negative 4. That's 10 to the negative 3.2. Use that as my concentration of hydronium with my volume to come up with the number of moles of hydronium. Using my mole ratio, predict the amount of sulfuric acid, and then working with the molar mass to come up with the actual mass that would be required. So that's how we can use the pH formula in a stoichiometry question.